All right. So we said that in short, quadratic function describe parabolic relationship and are easy to recognize by their squared term and are essential in both theory and real world problem solving. Okay. In this section, we want to look at what the step to find maximum and what minimum of a quadratic function. Okay. Yes. And one, what is the first step saying? Identify the quadratic function. Okay. Identify the quadratic function. So after you are done identifying that this is in the form of ax plus bx plus c, what is the next thing you're supposed to do? You're supposed to what? Also ensure that we are still in step one. Oh. You're supposed to ensure that a is never equal to 0, as if a is equal to 0, it's going to make your function become a linear. And if it's linear, you can't solve it in terms of quadratic. Okay. Secondly,
Okay.
in step 2, what do? You have to determine whether it is a minimum or maximum. Okay. And what did I say? How do you know whether it is maximum or minimum? Can you throw a little bit of light on that for me, even before we proceed? How do we know whether a curve is maximum or minimum?
When the coefficient is negative,
Thank
it's
you.
maximum.
Thank you very much. Okay, so that is the only thing I wanted to hear is when the coefficients. Okay, yes. So when the coefficients is hot, negative, it has a meaning. It gives, if the coefficient is positive, it also has a meaning. It poses to the hot listener. Okay, yes. So you had it correct. You had it correct. All right, all right, all right. So in our second step, you determine whether it is a maximum or minimum. Okay. So that is, we have to look for the coefficient. Okay. And I told you, if the coefficient is negative, it is a what? A maximum. And if the coefficient is positive, it's going to be a what? A minimum.
Minimum.
Okay. It's going to be a minimum. So this one, what do you think? What do you think is the meaning of some of these things? If you see that 0 is greater, it means that the a is what? Negative. And if
Negative.
it's negative, it's going to be what? A maximum curve. Okay. All these points are going to point what? Downwards. That is what it's trying to say. Okay. Parabola opens downwards. So you can see it opening downwards. Okay. And this one, the first one means that the A is positive. So it's going to what? Open what? Upwards.
Upwards.
Yes. It's going to open upwards. Good. Okay. Here too, in our step 3, they say we should find the coordinates of the vertex. Okay, so you know how to find the coordinates of vertex. So the coordinate of the vertex, the coordinate of x at the vertex is calculated with the formula hot. This, that is x at hot, v is equal to what? Minus b over hot over 2a. Is that not it?
Yes.
So secondly, you also come and do, after finding that, you also have to come and find the coordinate of the vertex at y. Okay, you have to find the y coordinate of the vertex. So by doing that, you have to substitute what? Your v of x or your v at x into the original function. Okay, and you can see as it is being substituted into the original function. The original function is what? Can you mention the original function for me? What is the original function? The original function,
Yes.
come again. The
In the
original,
AS squared, f of x equals AS squared.
yes. So the original function is equal to what? Ax squared
Squared plus
plus
bx
bx plus
plus c.
plus c. Okay, so this is the original function. Okay, so at the end of the day, if you come and calculate your vectors at x, okay, you are going to just put it into it. So look at in this equation, anywhere they saw x, what did they put over there? Anywhere they saw x, they went to put x subs with v over there. You see?
Mm.
So that is what is happening in just this step. So we are almost done. We are going to be solving the question we just solved in your book that is using so many steps. I'll be using a short step to solve it for you to see. Yes, to solve it for you to see. And also, in your fifth step, you are going to state the vertex point, whether it is minimum or maximum, which I think for now you already know. Okay. At the end of the day, your vertex is given as a what? As a coordinate. Okay. That is the vertex I said is the turning point of the graph. Okay, and this point gives the minimum or maximum value depending on the what coefficients, which is the A I told you about. And also in interpreting the results as to whether A is positive or negative, will tell you whether it will be minimum or maximum. Okay, in this case, in this case, in this case. And also if A is what? If A is positive, it means that your graph is going to be minimum and it occurs at x is equal to what? Occurs at x is equal to x at the turning point. And also, if your graph is hot, the meaning of this is if your A is hot, negative, it implies that your graph is going to be maximum, okay? And it's going to occur at, hello,
Hi.
okay, at x is equal to what? The turning point at the vertex, okay? So this is just a practical example I want to use to explain whatever we have been talking about to you, even before we use this method to solve your own questions in your book. All right. So in this is an example. They say we should calculate for the we should calculate for this. Okay, and you can see that this is a quadratic function. It is given in a form of 2x minus 4x plus 1. Okay, good. First of all, we have seen that our coefficient is hot. A is hot, positive. So once A is positive, the graph is going to be a hot
Minimum.
minimum. Okay, once A is positive, the graph is going to be minimum. That is why you have seen that you have written minimum over here. Okay, and in the second, then in the second step, what do? We have to find for the vertex at the coordinate. That is the vertex at x. And the vertex at x, how do we get? You see the formula is equal to what? B over negative 2a. This is the formula. You see the formula. So at the end of the day, if we by substitution, what is let me do you a short test. What is going to be the value of a over here? What is the value of b? And also, what is the value of c? Tell me. What is the value of a from the quadratic equation I just settled over here? What is the value of a?
A is 2. No, 2x squared.
A is just 2. A is just 2, the coefficient.
Okay.
Because we say it's in the form of ax. Let me quickly write that here again. Okay, you finish. And what is b?
4.
It's a lie. It's negative 4.
Hey.
And c is what?
1.
Yes, and c is 1. Okay. So those are the what is actually happening, because we say it's in the form of ax squared plus bx, okay, plus c. So anytime you have your question, this is the first thing you're supposed to put down. That is going to help you to solve your work. And you identify your A, you identify your B, you identify your C. Now you can proceed. Okay, so in this formula, you just substitute negative B over 2A. You just, by substitution, you're going to get your X at A to be what? 1. And also, for the second one, too, you realize that from substitution, what are we going to get? From substitution, we are just going to re-put the 1 into our original equation. Okay, the one I circle with blue. So after putting the 1 into the equation, you realize that they had what? Negative 1. So at the end of the day, our vertex was found at 4. And what is the vertex of the line? Can you mention the coordinate of the vertex for me? What is the coordinate of the vertex at the end of
The
the
one in front of line.
Come again. So the coordinate of the
Is
vertex.
the one if underlined?
No. The coordinate of the vertex is what? You watch, is 1 comma what? Negative 1. That is the one I put asterisk at the side of it. Can you watch? Can you see what I've just done?
Okay. Yes.
That is what I have just done over here.
Yes, please.
So at the end of the day, how are you going to call the first one? At the end of the day, how are you going to call the second one? So you see that at the end of the day, this one is going to be called hot, because if you want to mention, always I told you x before y. So this is going to be hot, x at hot, v. Okay. And this value is going to be hot, x at hot,
Okay.
y at v.
Okay.
This
Y.
is also going to be y at v.
Y.
So this is going to be y subscript what? V. So you see, so at the end of the day, I'm having y subscript v, x subscript v, comma what? Y subscript v, which is the vertex we are having over here, the one I'm just underlining with green pen. You see? So at the end of the day, what is the minimum value of the graph? The minimum value of the graph occurs at what? The minimum value of the graph is what? -1. Okay. And the minimum value, to always get the minimum, is y that is going to tell you. Okay, because as to whether the graph is going to be minimum or maximum, it is actually moving in the y axis. Okay. So the y axis is always going to tell you that. Okay, that is why you can see the -1 is what was being used to what denote the what. The minimum value is occurring at what? Negative what? 1. And the turning point itself, the one that is causing the -1, is what? Is the 1. Do you understand what I'm trying to insinuate? Hello?
No.
I'm saying that the turning point is caused by what? The turning point, if an object is spinning at a place, the turning point is caused by what? X. Do you understand me? The
Yes.
turning point is caused by X. Okay. And
Okay.
it is displaced by what? Y. Is that not it? So that is
Yes.
why they are saying that what? Our y is equal to what? -1. So they are saying that the minimum value of the curve is equal to what? -1. Can you see? If you don't understand what I'm
Yes.
saying, let me plot it on the graph for you to see. If you want to plot this on the graph, what is it going to be? If here is what? 0. Now at the end of the day, to plot this on the graph, where is this going to be? Let's say here can be 1. Okay. And is this not the y-axis? And here is going to be the what? X-axis. Can you see my screen?
Yes.
So if here is also 1, so at the end of the day, you see that the curve is somewhere here. Okay.
Okay.
So the x-axis is 1, and then the y-axis is also what? 1. So at the end of the day, my coordinate is what? Let me say, no, but one person was negative and one person was positive. Do you remember?
Yes.
Yeah, so we have to let that reflect in our in the graph that we are drawing. Who was negative? It was rather hot.
Y.
It was y that was negative. So why do we, so let's say the -1 is going to be somewhere here. The -1, right? So at the end of
Yes.
it, we're going to get what? 1, comma what? -1. Okay. So you see how the curve is going to look like. And the turning point, since they said the turning point is occurring at what? The turning point is going to be what? 1.
1.
So it means that the graph is going to be something like this. You see, because the coefficient,
Okay.
is what?
Okay, that's 2.
Hello?
Uh,
Because the coefficient is just positive, okay? Because the coefficient is positive, okay? You don't just say it's 2. Because the coefficient is positive, it's going to be a what? A minimum graph. Do you agree with me?
yes.
It's because the coefficient is positive. That is why it is giving us a what? A minimum graph. That is why it is giving us a minimum graph. So if we want to plot, where do you think the point is going to be? If here is 1, and maybe here is also -1, realize that the point is going to be somewhere here. Okay. So at the end of the day, to plot our curve, it implies that this will have to come and go something like this. Do you see what I just plot over here?
Yes.
So this is how the graph is going to look like. This is how the graph is going to look like. Okay. This is how the graph is going to look like. Okay. Do you have any question to ask before we proceed?
No. No question.
You don't have any question to ask?
For now.
All right. So if I give you an example now, do you think you'll be able to solve and tell me the answer? Okay, let's continue. So the summary of whatever we just solved, please mute your mic to avoid further noise, okay? So to further
Okay.
to simplify whatever I've been talking about, our step one, we say first of all, you have to identify what A, B, and what C. Secondly, you have to what check for the sign what A, and that is going to tell you whether the graph is minimum or maximum. To get your vertex at A, you have to use the formula what negative B over what 2A. One day we'll prove the almighty formula and you see how this formula was also what obtained. To get your what your Y subscript V, okay, you have to just substitute your turning point into your main equation and you are going to get the answer, okay. Finally, you have to come and conclude the minimum point and the maximum point of the curve, and then you are good to go. Is that clear? Hello? Hello? All right. So we are going to be continuing from our example, what? Example 3, okay? Let's say we are going to be continuing from example 3. And then in our example 3, how are we going to be going about this question? Okay. I'm going to still pick the first problem we solve in your book. Okay. And let's see how best we can be able to use that to simplify the work. Okay. Good. And the problem says we should what? Find the minimum okay, find the minimum value of f of x. Find the minimum value of f of x is equal to what? 3x squared minus x minus 6. Okay, good. And for what for what value of x does it occur? And for what value of x does it occur? Does it okay? Please, are you listening to me? Are you following?
Yes, please.
Okay. And for what value of x does it what? Okay, so just from whatever we saw, we want to adopt those steps to see if we can be able to use it to solve our problem. Okay. And from whatever we spoke about, do you have any question to ask so far before we proceed?
No, please.
Okay. So first of all, we have to what do we have to do? Now you are the one who's going to be teaching me, because I've already taught you everything. So first of all, what do we do? We have
What's your
to
question?
repeat the question for 1 mark. So this is the question. F of x is in the form of 3x squared. 3x
Minus x.
exactly. So 3x squared minus x minus 6. Was that the first question we saw from your book? Was that how it looked like? Yes.
Yeah.
That was exactly how it looked like. Okay. So we are coming to
Yes.
start solving our work in steps. Okay. So first of all, we are coming to what? Step 1. Step 1. And in the step 1, we have to identify our A, B, and C. Do you agree?
Yes.
So this is my A, this is my B, and this is my C. Okay. So my A is equal to what? 3.
3.
The B is equal to what?
-1.
-1, and the c is equal to what?
-6.
-6. Good. So I'm coming to take my step 2. And in the step 2, what do we do? In the step 2, what do we do? You see, once I'm writing, you also have to have a pen and a paper so that at this stage, you could have also written that, or you take screenshot and write it quick. You see, in online class, you have to be smart. Oh. What if the lecture never sends you the video again? You see, in the video that I'm doing now, once I discover a mistake in the video, it means I can't send it to you anymore again. Okay, because
Okay.
there is a mistake in the video, it means that if someone also sees it, I'm not a good teacher. That is one thing that happens. Okay, so if the video is not good, we don't share it. Yes. So you have to be writing so that at the end of the day, even if I don't share the video, you have it. Okay. So in our step 2, how do we go about the step 2? How do we go about the step 2? The step 2, we have to identify whether it's a minimum or what? Maximum.
Maximum.
Okay. So in this case, what can we say? We can say that what? Our A is equal to what? Positive. Okay. Our A is positive. And it is telling us that our graph is going to be a what? A minimum. Do you agree? Hello?
Hi.
Do you agree with me?
Yes, please.
So the graph is going to be minimum. The graph is going to be minimum. Okay. So also, what do we do next? We come to our step what? Step 3. Quickly tell me what you are going to be doing in the step 3.
We find it. Uh, the the x of
X at v, okay? The vertex, or you can say
okay.
that the vertex at x, it is still the same thing. Okay.
Okay. Okay.
So for the vertex at x, which formula did you say we are supposed to apply? So the vertex at
Negative b over 2a.
exactly. Now you don't like your form, the one in your book again. So you are going to get what? Negative what? B over what? 2a. Okay. And at the end of the day, after substitution, what are you going to get? Our x at v can be said to be what? Negative what? And what is the value of our b? So it
B.
will be what?
-1.
You -1 all over
Back.
2 into bracket. What do we have in the bracket? The a is what? 3.
3.
So I put my 3 over here. And at the end of the day, what am I going to get? Quickly punch all of this on the calculator and tell me the answer you're getting. Hurry. Quickly punch
Okay.
all of this in the calculator and tell me the answer you're getting. What are you getting?
I
Are you
get
getting 1 over 6?
1 over 6.
Are you not getting
Negative 1 over 6.
Eh? It's a lie.
1 over 6.
Eh?
Negative 1 over 6.
It's a lie. You didn't punch it well. Quickly punch it well.
Negative 1 over 6.
It's a lie. You're going to get 1 over 6, not negative 1 over 6. See, are you listening? From the formula itself, we have what? Negative b over 2a. Do you understand me? Hello?
Yes.
So if you from the
Hi.
formula, this is negative, this is the negative. And what's the value of the b? We said that the value of the b is -1. So I put all of here, I put -1 over here. As this is over here, punch everything in the calculator as it is. First of all, before you start, punch negative before you even bring your division sign, before you feed in the data. Okay. And you should be getting 1 over 6, not -1 over 6. Are you getting the answer that I'm getting? Or you call belief
Yeah.
to punch it for you to see?
I've gotten it.
Okay. So in our step 4, what are we going to be doing next?
And the radius of y.
Yes. So but you have to put down the formula first, else you lose marks. Okay, always put the formula down. So y at what? V is equal to what? Is the same as the what? Is the same as the f of x, okay, at V, okay, which is equal to what? Ax, okay, which is equal to a into brackets. This is still going to be squared. So in place of the x, I'm just going to put V over there. X V, S at with V, or X at V. It's not anything difficult. X at V, okay, plus
Okay.
what? Bx. But in place of the x, I'm going to put what? X at V over there. That is all what is showing. That is what f of x means. Anywhere you see x, you put x at V over there. Plus what? C. So this is the formula. And then from substitution, what did we get for our what? Our x at V. We had 1 over 6. So finally, I can see
Yes.
that what? My y at V is equal to what?
Because
So from the main equation, what is the main equation? We had what? 3x squared.
yes,
So the main equation was 3x squared.
spread
So I'm going to
minus
write 3, okay?
um,
Or yes, I'm going to write 3, and then in place of the x, I'm going to put what? What is the answer for x? Okay,
1 over 6.
no, you let me break it into sections, okay? Else you may get confused. So the real question that was given to us, our f of x was in the form of what? Mention it for me. 3x squared
Right.
minus x
Minus x
minus
minus 6.
6. So at the end of the day, now if you want to substitute everything into it, what are we going to get? Comma, but what? But our x at V is equal to what? 1
1 over 6.
6. So at the end of the day, if you want to substitute everything into the equation, what are you going to get? You realize that our y at V is now going to be equal to what? 3. Now, anywhere you see the x, you are going to put what? 1 over 6 over there. Still, you square it. I hope you are now getting the whole concept.
Yes, please.
So this is also 1 over 6 minus what? At the end of the day, your 6. So your y at V is equal to what? 3 into bracket 1 over 6. What are you going to get?
Yeah. 1 over 2.
Punch the whole thing into the calculator and tell me the answer.
Okay.
Punch the whole thing into the calculator and tell me the answer.
Okay.
So in 10-minute time, the link is going to go off. We will be left with one last small class, but because I'm having an online class, I will be going and come once I'm back
Okay.
and proceed. So what are you getting? What are you getting now?
Negative 73 over 12.
Shame on you.
Yeah.
Quickly cross-check your answer for me. Don't just watch into the book and mention straightforward answer. You said, what did you get?
Come. Negative 73 over 12.
So we are getting negative 73 all over what? All over 12. Okay. We're going to get negative 73 over 12. Okay. So we now know our vectors at x. We also know our vectors at what? Y.
Right.
So finally, what do? We have to come and conclude. Okay. So we are done. So in our step 6, in our step 5. So let me put over here step 5. In our step 5, I can finally say that um, my vectors, okay, I can state the vectors now. And my vectors are what? So my vectors at x and y, at x and y, okay? And the vectors at x and y, this is how I'm going to write it for you to see. It is denoted as what? Let's say, comma hot, that of y2. So this is the same as what? let me say 1/6, okay, comma hot, 1/6, comma hot,
Negative 73 over 12.
negative 73 over 12.
So,
So at the end of the day, what conclusion can you draw from this? From common sense, I told you that the x is always the turning point. Okay. So what can you say? The graph, did you say it's going to be a maximum or a minimum one? We say it's going to be a minimum, right? So from conclusion, what can you say? You can say that the graph is a minimum graph and it occurs at what? X, it occurs at what? X is equal to what? 1/6.
1/6.
Okay. And so what is going to be the maximum point on the graph? The maximum point or the minimum point? What is going to be the minimum point of the graph? From where we have gotten to, what is going to be the minimum point of the graph?
1/6.
Eh? No. The minimum point of the graph is what? Always. Take note. Take note. I said that what? X is always the turning point. X is equal to what?
Turning point.
Turning point. Because of you, I'm writing it again. No? Always the X is equal to the turning point. Okay. It's not even just X2, but X subscript V. Okay. Let me use a different color pen again. Let me use a different color pen again. Yes. So this is X subscript V. It's always the turning point, and Y subscript V is equal to what? Maximum or minimum. Okay. This one may either be the what? The maximum,
Or minimum.
okay, or what? Minimum. Depending on the what? The coefficient of A. Okay.
Okay.
Depending on A. So depending on what? A. And I hope you know what the A is.
Yes.
What? The coefficients. You
Yes.
understand? So from conclusion, what can you draw? Draw the conclusion for me to now see. So from conclusion, I can say that therefore what? Therefore, what conclusion can we draw? Hence the minimum value of the graph. Okay, I'm listening.
The minimum point is
So
negative 70 over 12.
yes. So when we hear point, always the point is going to be the y. Okay.
Okay.
Either the maximum or minimum point is going to be the y. Okay. And then the turning point is going to be the x. Okay. So hence we say that what? Hence the minimum point. Okay. Hence the minimum. Hence the minimum. Hence the minimum value. Okay. Hence the minimum value of f of x. And you know what f of x is? F of x is the quadratic function. Okay, that is being given to us. So the minimum value of f of x is what? Negative 73 over 12.
73.
So negative 73 over what? Over
12.
Yes. And it occurs at what? And where does it occurs at? Tell me. And where does it occurs?
The letter 1/6.
Yes, thank you. So it's always going to occur at what? X. Okay, which occurs at what? Exactly 1/6. Okay, so basically that is just a simple understanding or definition I can be able to give to you. Okay, yes. So you have the work like this. Do you have any question to ask from where we've started to where we have gotten to so far? Do you have any question to ask? It's not only tilted towards questions. Do you have any contributions to add to the study in order to validate our finding or research? Hello,
Mm,
do you have,
please no.
you don't have any contribution to add to the study? So you only came to take away from the study, but you didn't came to add to the study. Is that what you want to tell me? Hmm?
At least
At
I'm
least,
now learning to.
no, the reason I'm saying that is I gave you the book to go and learn. That is why you have the book. I
Yes.
said I wanted to take the book home. You said, no, I shouldn't take the book home. So I have to take pictures of your own book. That means that I'm learning software whilst you are learning hardware. Okay. So I'm expecting you to understand it much more better than me, or even since I've left the book with you, it means that you should even read before meeting me. Okay. So after teaching, oh, say I also have an addition to add to yours. So this one we can also solve it like this. You see, as I've taught you a different method, you also come and teach me a different method, and we see how best we can be able to move. What do you think? All right, all right,
Mm,
all right, all right. So, the method in your book and the method we just applied, which do you think is more favorable? Which do you think is more favorable? Which do you think is more favorable?
the the one we just did.
So, my last question for you is that I want to give you a question now for you to be to use to just tell me the turning point. Okay, I want to give you a question now for you to tell me the turning point. Are you okay by that?
Yes.
You. So you are going to give me the turning point at and the point at which it occurs. Okay. So once you have the answer, you can just send it to me on WhatsApp. I'll confirm that in 2 minutes time, the link is going to go off. And after my online class, I'll come back and catch up with you and we see how best we can be able to proceed from that. Okay. So quickly solve this. Okay. I'll be sending you the videos to watch. Quickly solve this and give me a feedback. So that is going to be our example 4. So our example 4. Okay, so listen to the question. You determine whether the graph is a minimum or maximum. Okay, and tell me the point at which it occurs. Okay, so the question is just 3x squared minus 6x plus 10 minus 6x plus 10. Okay, so quickly solve this and come and give me a feedback before we proceed. Okay. So
Okay.
solve this, determine whether it is maximum or minimum, and also tell me the point at which the maximum or minimum point occurs. Thank you very much. Have a wonderful day. Have a wonderful day. Bye-bye.
Thank you.